Okay. So what is the diffraction beta? So in the last session of your class, I told you bending of a light around the corners of some obstacles or holes is called as of your diffraction. And diffraction of light is significant only when the size of the hole or obstacle is in the order of wavelength of the light. And the phenomenon of diffraction is generally characteristics of your wave, and it is exhibited by all the waves like sound wave, water waves, matter waves, etc. Okay. So I have done even the proof for that one for maxima and minima by a single slit experiment. In the single slit experiment, the path difference has been calculated by the formula Cn is equals to b by 2 into sine theta. Okay, so angle, how do you calculate the angle of fringe width? Sine theta is equals to lambda by b. If theta is very small, then you can approximate sine theta is equals to theta, theta is equals to tan theta. Tan theta is equals to y by d. So y is equals to, where the first bright or first dark is calculated by the formula, y is equals to lambda into capital D by a small b. Central width formula వచ్చేసి 2 lambda into capital D divided by b. For dark point or destructive interference, sine theta is n lambda by b. For bright point or constructive interference, sin theta is equals to n plus 1 by 2 into your lambda by b. So we have done 1 or 2 examples related to that one. So let us try to go for the next one. Sure. Let us try to define types of diffractions beta. Types of your diffractions. First one. First one is Fresnel's diffraction. First one is about your Fresnel's diffraction. Fresnel's diffraction is nothing but a diffraction in which the distance of the source and screen are from obstacles are their finite distance. I mean to say the distance between the source and as well as of your screen is very finite from the obstacle. The first point you need to remember in this one is nothing but equal to distance of your source and screen from the obstacle are finite. That means if this is your screen, okay, and here somewhere is your source from which the waves have been coming. If the distance between the source and the screen, this one is nothing but screen, is finite, like say some distance b or anything we can take right now. So if I'm taking some source right now, on this one we'll be getting the center, we'll be getting the central maxima, I told you. Then immediately it is minima, then minima, then minima. Finally the interference will be something like this. That means as you are moving away, it will be continuously decreasing. Only the central part will be getting the maximum intensity. As you are going away on the screen, the intensity goes on decreases for this one. So this is nothing but of your I naught by 22. This one is nothing but I naught by 61, something like that go up. Okay. That is about your Fresnel's diffraction. So what is the Fresnel's diffraction? But I may ask you for a 2-mark question in your board examinations. Fresnel's diffraction is nothing but if the distance of the source and the screen from the obstacles are finite, such type of a diffraction which is happening is called as of your Fresnel's diffraction. Is that clear? So, next one is Fraunhofer diffraction. Fraunhofer diffraction. Fraunhofer diffraction. That means the distance of the source and screen from the obstacles are infinite beta in this one. So I can say in this one, distance of source and screen from obstacle is at infinite distance. Is it infinite distance? That means wavefronts in this one are plane wavefronts because the source is from the very larger distance. They appear to be coming from a very large distance. So I can say that wavefronts are plane because source is at a larger distance. When they are coming, there appears to be a light coming parallel. So as it is a parallel part affiliation, then if I draw a perpendicular line, that will give me the parallel wavefront. I mean to say plane wavefront part affiliation. Clear? Example for the Fraunhofer diffraction is single slit experiment. Okay. So in this one, see, I'm drawing the shapes right now. This is your screen. And somewhere here we are having the opening. And here is right now your lens. And source is at your very large distance. So the ray of light when it is coming from this one, this is something like this. Okay. Again, we are keeping one lens here right now, convex lens. The rays of lights are being incident on this one. They will focus at the center. Okay, so distance of this one from here to here is your focus F, and distance from here to here is also your focus of your F. The distance between these two slits will be equal to your A. So this slit and this slit mathala, single slit mathala distance is nothing but A. So A is your slit width. A is your slit width, and this is at your central maximum. Is it clear? And this is the source which is producing the sound. Sorry, waves part affiliation. Okay, if the distance of the source and screen from the obstacles are infinite distance, such type of a diffraction is called as a what beta? Fraunhofer's diffraction. The best example for this one is single slit experiment. In this one, the wavefronts will become for me plane. Clear? Single slit diffraction experiment already మనం చేశాము. So I need not tell you again related to this one. Okay. Sure. See this question, beta. A parallel beam of light of wavelength lambda is equals to 500 nanometer falls on a wave slit and resulting diffraction pattern is observed on the screen. 1 meter away. It is observed that the first minima is at a distance of 2.5 mm 2.5 mm from the center of the screen. From the center of the screen. Find the width of the slit. Find the width of your slit. And A value is equals to how much? Can anyone try better? Can anyone try? See, parallel beam of a light of wavelength 500 nanometer. So wavelength is given for me. Lambda is equals to 500 nanometer. That means that will be 5 into this will be equal to nanometer is 10 to the power of minus 9 into 10 to the power of 200 10 to the power of minus 7 meters. Capital D is given for me as of your 1 meter. It is observed that the first minima is the distance. That means y ichadu. Y value is equals to 2.5 mm. That means that will be equal to 2.5 into 10 to the power of minus 3 meters. If I'm writing that one. So what is asking right now? First minima. So first minima ki formula emunde chudandi now. Sorry, I'll just revise you this one. Chudandi. First minima is formed at what position? For minima, what is the given condition you see right now? For dark point or destructive interference. This is minima kada. So first minima ante n value will be taking it as of your 1. So for dark point or destructive interference, sin theta is equals to n lambda into your b. So I can write here n lambda into your b. For destructive or dark point or minima, d sin theta or a sin theta either represent చేసుకుంటున్నాం ఇక్కడ మనం. So it is your a into sin theta will be equal to n into lambda. Here n value is given as how much for me? 1. So a into sin theta will be equal to lambda. So as theta is very, very small, I can approximate this one as theta is equals to lambda by your a. Okay, so sin theta is equals to your theta part of relation. So we know that sin theta will be approximated to your tan theta and tan theta will be equal to y by capital D. Y value is given for me 2.5 into 10 to the power of minus 3. D is equals to 1 meters. Okay, that is approximated to your theta. Okay, so theta value is known for me. So he's asking the slit width and the A value. So A is equals to lambda by theta. So slit width is equals to wavelength. Wavelength is how much I got beta 5 into 10 to the power of minus 7 divided by this one is nothing but how much 2.5 into 10 to the power of minus 3. And that's not under sir. So this will become for me 5 ones and 5 0.5 until this will become for me 10 to the power of minus 7 into 10 to the power of a plus 3 divided by 0.5. 0.5 ante 1 by 2 అయిపోతుంది. So this will become for me 2 into 10 to the power of minus 7 plus 3. అంతేనా? So what is the answer for this one beta? 2 into 10 to the power of ఎంత వస్తుంది అన్న? ఎంత వస్తుంది? 2 into 10 to the power of slit width will be equal to how much for me? Minus 4. Okay, got an idea? So what is the condition you need to remember here? Only thing is for destructive interference or constructive interference, a sin theta is equal to n lambda, and for n is equals to 1. First minima anadu kabatti simplifying for that one, I got the value of your a part of relation. Clear for everyone? Is it clear? Sure. No question, Jordan. Save example. We got two slits. Two slits are made 1 mm apart. 1 mm apart, and screen is placed 1 meter away. 1 meter away. What should the width of each slit be obtained 10 maxima of double slit of your double slit pattern within central maximum within your central maxima of your central slit pattern. Two slits are being made 1 mm apart. Two slits are being made 1 meter apart and screen is being placed 1 meter away. What should be the width of your each slit to be obtained? 10 maxima of double the slit pattern, and 10 times of your fringe width is equals to your, what is telling? 10 times of your distance between them. That means 10 beta is equals to 2 times of your y, isn't it? So what should be the width of each slit which been obtained? 10 maxima. For maxima, what is the relation I can write now for me beta? So it is right now double slit experiment kabatti. Theta will be equal to your y by your capital D. Okay, that is equal to how much for me? Lambda by your a. That means y will be equal to your lambda into capital D divided by your small a. So this will be equal to your 10. Fringe width formula is how much beta? Beta is equals to, we know the RAM formula, capital D into lambda divided by your small d is equals to 2 into, this one is lambda into capital D divided by your slit width. That is nothing but equal to your a. This d, this lambda will get cancelled. So it is a 10 by your d will be equal to 2 divided by your a. Okay, so this will become how much for me beta? 2 ones are 2 fives are. So I can write here right now for this one is 5 by d is equals to your 5 by d is equals to your a. 5 by d is equals to your a. So again right now in the problem, two slits are being obtained. What should be the width of each? That means a value is equals to your how much? As a given amount of anything, two slits are made up of 1 meter. Small d is the distance between them. That means small d is equals to 1. So that means I can write this a is equals to 5 by over 1. Then a equal to 1 by a 5 by d, sorry. Five by d is equals to 1 by a, and a will be equal to how much for me beta? D by 5. D is equals to 1 divided by 5. So it is 1 by 5 mm. 1 by 5 mm is that will be 0.2 mm. Clear beta? Okay. The problems in Panani almost so almost like same thing for the given condition. Sure. Let us try to go for the next concept beta, resolving power. Very important for competitive examination beta. So first one is your resolving limit and resolving power, and your resolving power. Is actually optical instruments and the Japala, but right now just you try to remember the formulas, that is more than enough for me beta. So resolving limit and resolving power and the linear or angular separation between any two objects for which they can be just resolved. Like say if the BPC students are there, they may be understanding like if you are seeing any microorganisms like amoeba, paramecium through your optical instruments. What are the optical instruments you will be using? Microscopes for them. Compound microscopes or maybe a highly sophisticated microscope, where a small object can be seen as of your, it can be seen as of your two different objects separately, isn't it? So making them very enlarged, like zooming, I can say, like even if you are having our cameras with us, we have 2x zoom, 3x zoom, 4x zoom, 6x zoom, 16x zoom, 32x zoom. That means you are increasing that number of times. And if it is 1x, I can zoom it to say for example 4x. I can zoom to it say for example 8x. I can zoom it to say for example 12x. I can zoom it to say 16x or maybe 32x or maybe 64x or 100 times of your x. That all depends upon the instrument what we are using. That means magnifying the objects to a larger extent so that it can be seen very easily is called as of your resolving. Like say for example, if there is a distance star, isn't it? If you are standing on the earth and seeing a star, we may be feeling that two stars are appearing as one single star because they are very large distance, but at very large distance, like say for example, these are two distances right now. These are two stars right now. If I'm seeing it from the infinity, if I'm seeing it from infinity, the angle will become from this one very small, like 1 degree, half degree, maybe 0.002 degree. At that time, these two objects will be appearing to be as of your one single object. So a single object need two objects ka differentiate chesi or lekapothe exact distance between them will be using the microscopes or maybe sir telescopes part of relation that will be doing in the ray optics chapter. So, but right now, you just remember here right now, resolving means increasing the capacity to see the objects very easily. That is called as of your resolving power. So you can just write the definition here. So what is the resolving power means? The linear or angular separation or angular separation between two objects for which they are just resolved in an optical instrument is called its resolving limit. Okay, and the reciprocal of resolving limit is called as resolving power beta. The reciprocal of resolving limit is called resolving power. Okay, so we need to remember this one. Resolving power means the reciprocal of your resolving limit. So I can say the linear or angular separation between any two objects for which they are just resolved in an optical instrument is called as of your resolving limit. The reciprocal of resolving limit is called as of your resolving power. We are having some standard formulas, but the derivations of this one is not included in syllabus, so don't bother about the derivations. For microscope, if I'm going it, for your microscope, the resolving limit is being given by the resolving limit is given by writing the formula here. D theta is equals to 1.22 into lambda divided by 2 times of mu into your sine theta. So this is the resolving limit for the microscope. Formula man measure is the column. There is no other alternate. For your telescopes, if I'm going for telescope, the resolving limit is given by d theta is equals to 1.22 into lambda divided by your a. So that is your d theta. Okay. So I'll just write the terminologies of this one beta. Lambda is known as nothing but wavelength. And mu is nothing but what? Refractive index of object, or I can say that refractive index of medium between your object and objective eyepiece of microscope. అంటే ఐ దగ్గర ఉన్న లెన్స్ యొక్క మీడియం మధ్యలో, అంటే ఆబ్జెక్ట్ అండ్ ఆ లెన్స్ పీస్ మధ్యలో ఉండే మీడియం ని మనం రిఫ్రాక్టివ్ ఇండెక్స్ తీసుకుంటాం. అండ్ theta is nothing but of your half cone angle subtended by each object at center. At your center, and something like this. If I take this diagram shape, or I can take this. ఇది center, ఇది cone అనుకో. So this is your half angle, that is theta, and this one is also theta. This is length కాబట్టి ఇక్కడ నుంచి ఇక్కడ వరకు ఈ aperture. So this one is nothing but of your A. A is nothing but what beta? Diameter of objective piece. Diameter of objective of eye of your telescope. And lambda is nothing but of your wave. Clear? So these are the two standard formulas you need to remember in the resolving power for your exams. For microscope, it is 1.2 lambda divided by 2 mu into d, and d theta is equals to, for the resolving limit for the telescope is this one. Now, if I'm asking the resolving power, but resolving power anyone tell me how do you write the resolving power? So resolving power is equals to 1 by d theta. And here also say resolving power will be equal to 1 by d theta. That will become for me your A divided by 1.22 into lambda, and here it will become for me 2 mu into your sine theta divided by 1.22 into your lambda part of it. Clear? So this is about your resolving power of this one. Clear, beta? So for this, we have been completely done with your diffractions, whatever is there for competitive examinations. దీని పైన కొన్ని ప్రాబ్లమ్స్ మనం తీసి ఒకవేళ చేయగలిగితే దట్ విల్ బి మోర్ అండ్ మోర్ బెటర్ పార్టికులేషన్. కొంచెం థియరీ క్వశ్చన్స్ కూడా ఉన్నాయి దీనిపైన, అవి కూడా నేను ఒకసారి చేపిస్తాను. వాట్ ఆర్ ద లిమిటేషన్స్ ఫర్ విచ్ వీ కెన్ సీ ద డైఫ్రాక్షన్ అండ్ యాజ్ వెల్ యాజ్ ఆఫ్ యువర్ ఇంటర్ఫియరెన్స్ అనే కాన్సెప్ట్ కూడా ఉంది. దట్ ఐల్ ట్రై టు టెల్ యూ. ఓకే, అది రే ఆప్టిక్స్ లో చెప్పేటప్పుడే చెప్తాం మనం స్టార్టింగ్ లా డైఫ్రాక్షన్ కి కండిషన్ ఏం కావాలా, రే ఆప్టిక్స్ కండిషన్ ఏం కావాలనేది. But still, if it is been required here, some numerical questions also you can do based upon that given condition. And in the tomorrow session of a class, we'll try to start with your last topic of this one. Tomorrow is what? Sunday. Sunday is not possible. Monday, we'll try to complete your polarization. In this weekend examination, if they are keeping any exam for you, the syllabus will be only the wave optics, YDSC and diffraction. YDSC and diffraction. Okay, na?
Okay, sir.
Yes, sir.
Let me check if I can get some more good questions related to your diffraction. ఇంటర్ఫియరెన్స్ పైన ఏమైనా ప్రాబ్లమ్స్ పంపించాను మీకు నేను?
Sir, once scroll down, sir. No, sir, only till that parallel beam of light question. Enough, sir, enough, sir. Thank you, sir.
Cheers. Optical instrument పైన ఒక చిన్న క్వశ్చన్ రాసుకున్నాను. This was been asked previously in the competitive examination. The diameter of the objective lens of microscope makes an angle beta. అంటే theta బదులు ఇక్కడ కూడా beta ఇచ్చాడు. At the focus of the microscope. Okay. Further, the medium between the object and the lens is an oil of refractive index n. mu బదులు n ఇచ్చాడు బిడ్డ. Then resolving power of microscope is first option. Options are also given. First option is increases with the decrease in value of n. Increases with decreasing value of n. Number 2, increases with decreasing value of beta. Third one is increases with increasing value of your n into your sine 2 beta. And fourth one is increases with increase value of 1 by this is your n into sine 2 beta. So this is a question. Try to read it out better. The diameter of the objective lens of your microscope makes an angle of your beta at the focus of microscope. And angle is very, very small beta. Focus and angle is very, very small. Further, the medium between the object and the lens is an oil of refractive index and the mu. Then he's asking the resolving power of microscope. In the resolving power of a microscope is how much better? I'm writing here right now. So resolving power of your microscope is equals to. What is the formula right now for this one? 2 mu into sine theta. That is nothing but 2 into mu is nothing but n into sine theta value is your beta divided by n is right now your refractive index divided by 1.2 lambda. 1.2 lambda. So resolving power is directly proportional to your 2 times of your n into sine beta. So I can write here sine 2 beta will be equal to how much beta? Sine beta into your cos beta. అంతేనా? 2 sine beta formula ఎంతనా? అంతే కదా?
Yes, sir.
Isn't it? So sine 2 beta will be equal to your 2 sine beta into your cos beta. For small beta, I can write here for small value of your beta, cos beta will be approximated to 1 trigonometric approximation. That means resolving power will be proportional to your. So sine 2 beta can be written as of your 2 times of your sine beta. So that is nothing but of your n into your sine of your 2 beta. Right, yeah? 2 sine beta can be written as of your sine 2 beta. So resolving power is directly proportional to your n into your sine beta. That means it increases with the increasing value of your n into your sine beta. Is that clear? Is that clear?
Yes, sir.
And today what I'll do is I'll try to send you some assignment on your YDSC and as well as of interference and as well as of a diffraction beta. ఎన్ని అయితే అన్ని మీరు రేపు సండే కూర్చొని చేయండి, రాకపోతే మండే ట్యూస్డే క్లాస్లో మనం దీనిపైన న్యూమరికల్స్ అయిపోగొట్టుకొని then we'll try to start with your diffraction because it is scoring topic in formula based examination for final examination beta. Waves is a directly formula based question. మన క్వశ్చన్ పేపర్స్ చూసారా ఎట్లా ఈజీగా వస్తున్నాయి క్వశ్చన్స్? డాప్లర్ ఎఫెక్ట్ పైన కూడా 2 క్వశ్చన్స్ వచ్చాయి, చూసారా లేదా మీరు? చూసారా సౌండ్
Sir, when sir?
మన ఎగ్జామ్ జరిగే కదా జేఈ మెయిన్స్ లో 21 20 ఫైనల్ జేఈ మెయిన్స్ లో మనం క్లాస్ లో చేసిన యాజ్ ఇట్ ఈస్ క్వశ్చన్స్ డాప్లర్ ఎఫెక్ట్ లో వేవ్స్ లో డిట్టో క్వశ్చన్స్ డాప్లర్ ఎఫెక్ట్ చేసామా మనము?
Yes, sir.
మన పేపర్స్ కూడా పంపించాను మీకు, ఒకసారి చూడండి. ఐ హావ్ సెండెడ్ యూ సమ్ ఆఫ్ ది పేపర్స్ రిలేటెడ్ టు యువర్ జేఈ మెయిన్స్ పేపర్స్. బైపీసీ స్టూడెంట్స్ కెన్ ఆల్సో సీ ఇట్ అవుట్ బెటర్. Directly formula based. Only thing is on that time the thing is you should able to recollect the formula. With the difficult questions ఏమీ లేవు బేసికల్ గా. మీకు పంపించాను చూడండి ఒకసారి, పంపించలేదా? గ్రూప్ లో ఉండాలి చూడండి. First law of thermodynamics పైన డైరెక్ట్ క్వశ్చన్, elasticity direct question. Vectors like the projection అడిగాడు అంతే. Projection of your A, projection of your B. See. J means shift 1 2021 20th 20/07/2021 కి జరిగిన క్వశ్చన్. డాప్లర్ ఎఫెక్ట్ లో చూడండి క్వశ్చన్ ఏమి ఇచ్చాడు వాడు. ఈస్ టెల్లింగ్ దట్ ఏ వెహికల్ మూవింగ్ with velocity v and releasing sound of frequency 400 hertz, listening the reflected sound from a wall of frequency 500 hertz. Find velocity of vehicle. This is the question. So we got a vehicle which is been moving with a velocity of your how much beta? V. So this is your wall. This is acting as of your reflector. So this is your wall and this is your vehicle. This vehicle is producing sound and is moving in the front direction. With what velocity? Velocity of your V, isn't it? So frequency received by the wall will be equal to how much beta? Frequency received by the wall. Frequency received by wall. And the apparent frequency kada, n dash will be equal to your n into who is at rest? Observer. Wall is acting as of your observer. So it is V by your velocity of sound is in the same direction and velocity of the source is also in the same direction. So this will be equal to your velocity of sound is Vs minus of your V. Okay, Vs is nothing but here velocity of sound. Vs is your velocity of your sound. Clear? Now, reflected frequency received by man will be equal to how much beta? Reflected frequency received by man. And n double dash kada? N double dash is equals to your n dash. So that will be equal to your n dash into your velocity of sound plus this is your observer. It is to be taken as a mirror image. So that will be equal to your V divided by the next one should be taken as of your rest. So this will be your velocity of source. Ante kada? n dash value దీనిలో substitute చేసుకోండి. n double dash is equals to n dash value is nothing but equal to your n into this one is your v divided by vs minus of your v into this one is your vs plus of your v divided by your velocity of your sound. అంతేనా? So this one is also your velocity of your sound ఇక్కడ. This is also your velocity of your sound. VSA this one. Velocity of observer 0 kabatti. So this one is also velocity of your source sound. This one and this one will get cancelled. So n double dash will be equal to your n into formula is for me Vs plus of your V divided by Vs minus V. ఇది డైరెక్ట్ గా గుర్తుపెట్టుకోవాలని డిరైవ్ కూడా చేసిన నేను క్లాస్ లో. గుర్తుందా లేదా మీకు? గుర్తుందా? చెప్పాను నేను క్లాస్ లో. అవునా? Separate frequency is given for me 500. That is equals to your actual frequency is equals to how much for me given for me 400 into your velocity of your sound is nothing but of your 330 plus V divided by this is your 330 minus of your. Just cross multiply and simplify it. We'll be getting the answer for this one. This 20, this 20 will get cancelled. So 5 by 4 is equals to 300 plus V divided by 330. 330. So this is 330 minus V. So this one is 330 minus V into your 5 is equals to 330 plus V into your 4. Yes, sir. Yes, sir. Now tell me 330 into 5 is how much, beta? Because of 15, 16 calculation. So it is 1650 minus 5V is equals to, if I'm writing for this relation right now, 330 into 4. 330 into 4 is how much better? 1320 plus 4 times of your V. Okay, na? So minus if it is going there and this side, this will come here right now. So if I'm writing for this in 1650 minus this one is nothing but equal to your 1320. That will be equal to 4V plus of your 5V. Antena? ఎంత వస్తుందన్న 1650 minus 1320 ఎంత వస్తుంది 330 is equals to this one is 9V. So V will be equal to 330 divided by 9. అంతేనా? 330 divided by 9 అంటే ఎంత? 36.66 something meter per second. Okay, simple question. ఇది నేను క్లాస్ లో ఆల్రెడీ చెప్పిన derived formula as it is formula. డైరెక్ట్ ఫార్ములా బేస్ పైన వచ్చింది. ఓన్లీ థింగ్ ఇస్ కేసు గుర్తుపెట్టుకొని ఓన్లీ మీరు ఫార్ములా నేర్చుకుని పోయినా కూడా డైరెక్ట్ క్వశ్చన్ చేసి వచ్చే క్వశ్చన్ ఇది బేసికల్. ఓకేనా? మన జేఈ మెయిన్స్ షిఫ్ట్ లో అడిగిన క్వశ్చన్స్ ఇంకా మిగతా క్వశ్చన్స్ కూడా ఉన్నాయి, అవి కూడా ఒకసారి మీకు పంపించేస్తాను. సో దట్స్ ద డైరెక్ట్ క్వశ్చన్స్. అంటే what I mean to say is all the questions which are right now coming from the NTA or almost like a formula based. Only thing is the more you revise, the more you reproduce. That is important. Rather than doing the level 5, level 6 type of questions at the time, you need to concentrate more on your solved examples, level 1, level 2 and level 3. level 3 వరకు కూడా పోకపోయినా కూడా పెద్ద రోగాలు లేదు, కానీ level 1, level 2 మాత్రం ఖచ్చితంగా 2 ఎక్కం 2, 2, 4 ఎట్లా చదువుతారో ఆ లెవెల్లో మనం level 1, level 2 పర్ఫెక్ట్ గా ప్రాక్టీస్ చేస్తే you can crack the NEET examination as well as of your NIT examinations very easily. ఎందుకంటే almost all the papers are formula based. There is no questions which is been like a derivative and which is of a lengthy manner participation. ఒకవేళ 1-2 lengthy ఉన్నా కూడా అది తీసి పెట్టేసినా కూడా remaining all the 20 questions or 25 questions are purely formula based. So even an average student, if he can able to do a topic పైన solved examples ఒక 50 solved examples level 1, level 2 మీ కాలేజ్ మెటీరియల్లో 2-3 సాల్వ్ చేయాలి అంతే. అండ్ ప్రీవియస్ PYQs అంటే ఒక వేవ్ ఆప్టిక్స్ పైన ఒక 100 క్వశ్చన్స్ చేసుకొని పక్కన పెట్టుకొని రిపీటెడ్ గా అదే చేస్తూ ఉండండి అనుకోండి, యూ విల్ బికమ్ పర్ఫెక్షన్. ఎందుకంటే డాప్లర్ ఎఫెక్ట్ చూడండి ఎంత ఫార్ములా బేస్డ్ వచ్చిందా, వేవ్ ఆప్టిక్స్ కూడా అట్లే ఉన్నాయి. మరీ డెప్త్ లో వెళ్ళి level 5, level 6, level 7 చేసుకుంటూ కూర్చొని టైం వేస్ట్ చేయడం కంటే కూడా level 1, level 2 సాల్వ్ ఎగ్జాంపుల్స్ చేసి ఒకసారి చేయడం కంటే కూడా 20 సార్లు చేయండి వేవ్ ఆప్టిక్స్ ని, వేవ్స్ ని 20 సార్లు చేయండి. If you're doing 10 times, 20 times the revision, then the fastness will increase and you also have a time to revise like that. వేవ్స్ ఒకవేళ కూర్చుంటే అన్ని ఫార్ములాస్ ఒక 1 అవర్లో అయిపోతాయి. రోజు ఒక 10 ప్రాబ్లమ్స్ చెప్పిన చేసినా కూడా ఒక 1 మంత్ లో అన్ని మోడల్స్ అయిపోతాయి. అవే ఒక 100 ప్రాబ్లమ్స్ లేకపోతే ఒక 150 ప్రాబ్లమ్స్ పెట్టుకొని వేవ్స్ లో అదే రిపీటెడ్ గా చేస్తూ ఉండాలి. ఇంకా కొత్త క్వశ్చన్ ఏం చేయకూడదు. అన్ని మోడల్స్ ఆ 100 లోనే క్లబ్ అయ్యే విధంగా చూసేసుకొని కంప్లీట్ గా చేసేయండి. దట్ విల్ హెల్ప్ యూ అవుట్ ఫర్ us. ఓకే?
Yes, sir.
ఈ వీకెండ్ ఒకవేళ ఎగ్జామ్ ఉంటే ఇట్ విల్ బి ఆన్ డాప్లర్, వాట్ యు కాల్ దట్ వన్, ఆన్ ప్యూర్లీ ఇంటర్ఫియరెన్స్ వేవ్ ఆప్టిక్స్ లో డైఫ్రాక్షన్ వరకు అనుకోండి అంతే. ఓకే ప్రణవ్, నువ్వు ఏమో పంపిస్తున్నావు ఏంద్ర? ఈ లింక్ ఏంటి నాకు అర్థం కాల. హూ ఇస్ ప్రణవ్? ఓకే చలో బెటర్ టేక్ కేర్ మేడం ఉన్నారు